Section 11.3.19. A random sample of 40 adults with no children under the age of 18 years resulted in a mean daily leisure time of 5.5 hours with a standard deviation of 2.56 hours. Another random sample of 40 adults with children under the age of 18 results in a mean daily leisure time of 4.61 hours with a standard deviation of 2.01 hours. We want to be able to construct and interpret a 95% confidence interval for the mean difference in leisure time between adults with no children and adults with children. Okay, so what we're going to do first is we're going to let the population mean 1 represent the mean leisure hours of adults with no children under the age of 18. So that means the first sentence is going to represent the population mean that has 40 adults with no children under the age of 18 years. That results in a mean daily leisure time. So the mean, and let me go ahead and rewrite that. So we have 40 adults with no children under the age of 18 years. That has a mean of 5.5 hours and a standard deviation of 2.56 hours. And then we're going to let population mean 2 represent the mean leisure hours of adults with children under the age of 18. So the second random sample is 40 adults with children under the age of 18 with a mean of 4.61 hours and a standard deviation of 2.01 hours. Okay, now the difference between two population means, population mean 1 and population mean 2, with unknown population standard deviations, approximately follows the student T's distribution if the following assumptions are met. The samples must be simple random samples, the samples must be independent, and the populations must be normally distributed or the sample sizes must be large. So the sample sizes are large, so we know that it satisfies that condition. The samples are independent because they're two different samples, and they're simple random samples. Now, to construct a 1 minus alpha times 100% confidence interval about the mean difference of two independent means, the following formulas can be used to approximate the bounds. We have x subscript 1 bar, which is the sample mean, n subscript 1, sample size, s subscript 1, standard deviation for population 1. X bar subscript 2 sample is a sample mean, sample size of n subscript 2, and standard deviation subscript 2 is a sample standard deviation for population 2. We also have the t alpha divided by 2 is the critical t value computed using the smaller of the n1 minus 1 or n2 minus 1 degrees of freedom. Now once we find the confidence interval, if the confidence interval does not contain 0, we conclude that there is sufficient evidence to reject the null. Otherwise, there is insufficient evidence to reject the null. So here are our formulas for the lower bound and the upper bound. Okay, so first thing is first, we want to identify the mean, the standard deviation, and the sample size for population 1. So, what is x bar 1? What is standard deviation for population 1? And what is the sample size for population 1? Well, we can see here that the mean is given to be 5.5 hours. The standard deviation is 2.56 hours. And the sample size is 40. Okay, now what we want to do is we want to find the sample mean for population 2, the sample standard deviation for population 2, and the sample size for population 2. Well, we know that the mean for population 2 is 4.61 hours. We know that the standard deviation is 2.01. And we know that the sample size is 40. Let me make sure that the mean is correct here for 5.55. Okay, now what we need to do is we need to find the critical value. So we're constructing a 95% confidence interval. So we're going to take 1 and subtract 0.95, which it gives us 0.05. And then we're going to take alpha and divide that by 2. So 0.05 divide that by 2 gives us 0.025. And then we need the degrees of freedom. We'll recall here that we use the smaller of the sample size minus 1. Well, they're both 40, so that means it doesn't matter which one we use. So the degrees of freedom is going to be the sample size 40 minus 1, which is going to give us 39. So now what we're going to do is we need to use our table. So the area is 0.025, and the degrees of freedom is going to be 39. So there's 39. And using our table, tells us that we end up getting a critical value of 2.023. So the critical value is equal to 2.023. Okay, so now what we want to do is we want to determine what is the lower bound by plugging in that information. So we know that we have 5.55, which is sample mean 1, minus sample mean 2, which is 4.61. And that's going to be minus 2.023 times the square root of the following. 2.56, which is the standard deviation of population 1, divided by 40, plus 2.01 squared divided by 40. So we want to be able to find our lower bound. So let's go ahead and then use our calculator to make sure that we're comfortable doing that. So for our calculator, we're going to do order of operations. Okay, we're going to start inside the parentheses. So we're going to take 2.56, we're going to square it, and then we're going to divide that by 40. And then we're going to add, we get 2.01 squared, and then divide that by 40. Okay, now that's underneath the radical. Now we're going to take the square root of this answer. So we're going to take second square root, and then write second answer, because it's pulling this answer here, and then hit enter. And then we're going to multiply it by minus 2.023. So times negative 2.023. Okay, and then we're going to add the following. We're going to take 5.55 minus 4.61. We put that in parentheses. And then we get the following answer. Okay, so we're going to round this to 2 decimal places. So we get negative 0.10. Okay, so now what we're going to do is we're going to do the same thing, okay, here. Okay, so we're going to end up doing the same thing. We're taking these values, but now what we're going to do is, instead of subtracting, we're going to add. So we want to be able to find the upper bound here. So let's do the same thing. So again, just to get used to the calculator, we get 2.56 squared divided by 40 equals, and then plus 2.01 squared divided by 40. Okay, and then we're going to take the square root of that, second square root of the answer, so second answer. And then we're going to multiply that by 2.023, which is positive. And then we're going to add parentheses 5.55 minus 4.61. And we get that answer. So let's go ahead and copy that. Okay, now we're going to round this to 2 decimal places. So we're going to say that the upper bound is approximately 1.98. So now that we found the upper and lower bound, we can now say the confidence interval is going to be the following. It's going to start at negative 0.10 and it's going to end at 1.98. So now we need to determine, is 0 in this interval, where it goes from negative to positive, so we can say that 0 is in there. So recall that if the confidence interval does not contain 0, we would conclude that there is sufficient evidence to reject the null, and then conclude that there is a significant difference in leisure time between adults with no children and adults with children. Otherwise, there is insufficient evidence to reject the null, so conclude that there is a significant difference in leisure time between adults with no children and adults with children. Now, since 0 is there, we can say that there is a 95% confidence that the difference of the means is in the interval. So the 95% confidence interval for population 1 mean minus population 2 mean is the range from negative 0.10 hours to 1.98 hours.